We use scatterplots to decide if there's a relationship between paired data. This data can have a positive correlation, a negative correlation, or relatively no correlation. So we're going to talk about these three things. A positive correlation is when the y values tend to increase as the x values increase. So if you see that the points have what looks to be a positive slope, it would be a positive correlation. A negative correlation happens when the y values tend to decrease as the x values increase. If the scattered points look like they have a negative slope, that is a negative correlation. And relatively no correlation happens when, I'm going to draw this one over here. Ooh, that marker is really, really thick. Hold on. There we go. If the graph looks like this, and you couldn't put a positive line or a negative line into that because like you could make a case for either, that means relatively no correlation. So on your assignment, the first three problems are just going to be asking positive, negative, or no correlation. You just have to see how scattered that data is, if it looks positive or looks negative. Okay, the steps to approximating a best fitting line are written here, but I'm just going to go through them because I think it makes more sense just to do the example. So we need to draw a scatter plot of the data and then approximate the line for the data. First thing we need to do is plot the points. So there's points provided here. Let's plot these points. The first one is -4, 8. Remember, x is side to side, y is up and down. -2, 5. Feel free to pause the video and get these points plotted. As you're getting those points plotted, does this line appear, or does this data appear to have positive correlation, negative correlation, or no correlation? Negative correlation. It looks like we could stick a line in there that kind of followed the points, and that line would have negative slope. Okay, I'm going to use a ruler for this. We need to approximate a line that fits the data. A line that fits the data needs to kind of, it's hard to explain, but it needs to kind of like find the average of the points. This line should follow the slope of the trend of the points. You want to have about the same number of points above the line as you do below the line. You want the line to seem like it fits. So I'm going to draw in a couple of bad examples. Well, I guess I probably shouldn't have told you bad, but do you think that pink line fits the data? I mean, it kind of does. There's about the same number above and below, but do you see how these points over here on the right are so far away and the points down here are so far away? If we tilted that line a little bit more, it might fit those points better. And then this is the weird, this is going to sound really weird. Don't try to go through original points, but don't try to avoid the points either. Does that make sense? Like, don't be like, I have to go through 2 data points, so I'm going to make the line like this because that definitely goes through 2 data points. You don't want to try to go through 2 data points, but if the line that happens to fit happens to go through 2 data points, okay, fine. How do you guys feel about that line? Let me draw that in. How do you feel about that line? You're trying to kind of average the distances between each point and the line. So I've got 4 to 5 points below the line and about 4 points above the line. I've got 2 points, one up here towards the top that's kind of far away and one kind of at the bottom. But most of the points are fairly close to the line. Do we feel okay about this line? Now, is your line going to be exactly the same as mine? No, it definitely is not. So this next part is where your work is going to look very, very different from my work and from your classmates' work. We need to find 2 points that are on our line. So I'm going to look through here, and it looks like right here I've got a point that I could easily find. And then I think this point right here. Notice I did not choose original data values, and I tried to pick 1 point on either side. You don't want 2 points that are super close together. You want to space the points out. So find 2 points that you could find on that line. So I think my points are -3, 9, and 6, -2. These are the 2 points on my line. Your line, you probably have 2 different points. But whatever points you have, we're going to follow the same steps we did yesterday. So step A is find the slope of the points that are on your line. So my line, if I find the slope, and this time it is totally fine to use decimals. You're going to have decimals. You don't want to leave this as -11/9. That's going to be really difficult to use. So make that as a decimal, whatever yours happens to be. Your second step is going to be to use one of the points and your slope and write the equation in point slope form. So y minus then your final step would be to distribute and get your final equation. Okay, so this is the equation that I got. I'm going to write down the equation that the computer says is the correct, best fitting equation. So the computer says that the best slope is -1.089 and that the y-intercept should be 4.79. So my y-intercept is a little bit high. I probably should have lowered my line a little bit. And it looks like my slope was a little bit too steep. We should have lessened it out a little bit. Here's how I would grade this if we were doing a paper copy of a test where you had to do this whole process. I would say that a slope anywhere from -0.9, probably -0.8 to -1.5 would be an appropriate range for your slope. So if your slope is somewhere within that range, you're doing all right. And a y-intercept somewhere between probably 4 to 6. If your y-intercept is somewhere between 4 and 6, you did okay. So if I was grading this on paper, I would look at, did you plot the points correctly? That's a point. Did you draw in a line that fits the data okay? That's a point. Did you pick 2 points on your line, find the slope correctly, write the equation, and then is your equation sort of okay in that range? Now we're going to figure out how to do this with the whole virtual testing, but we'll figure something out. Through this whole process again, and I'll use the purple highlighter to kind of highlight a few things. So step 1, carefully draw a scatter plot of the data. Make sure you're using graph paper and plot these points on the graph. Step 2, draw a line that appears to follow most closely the pattern given by the points. You want to try to have approximately the same number of points above the line as you do below the line, and you want the line to kind of mimic the apparent slope of those points. Don't try to cross original data points, but don't try to avoid them either. Then choose 2 points on your line. And I put in bold, these 2 points do not have to be original data points. In fact, it's often better if they aren't. So notice the 2 points that I picked. If I zoom in here, those are 2 points that hit those hash marks really well so I can find what those points are. They were not original data points. So pick 2 points that appear to be on your line, and it's best if you spread them out. You don't want to pick, here, I'll do this in orange. I wouldn't want to pick this point that I picked and a point like super, super close to it, because that's going to make your slope look funky. And then find the equation of the line that passes through those points. Find the slope, put it in point slope form. Decimals are fine. Distribute, you're going to have decimals, that's totally fine. The first one of these that you have to do on your assignment is a very similar data set to this example. I would strongly suggest that you do every other hash mark. So this would be 1, 2, 3, 4, and this would be 1, 2, 3, 4. We don't have any data values bigger than 5, so that will definitely fit on this graph. That will help space it out and make your points more accurate. Anytime you can make your points more accurate, it's going to benefit you in the long run. So plot these, getting as accurate as you can with that 0.5 scale. Pick out 2 points on your line, write the equation, all that good stuff. Okay, I plotted the points on here, and I drew in a line that I thought fit the data pretty well. And notice that my line goes through this data point at 0, 2.5. So my line goes through that data point, but I didn't choose it. I like to avoid those data points. I chose this one here, 0.52, and this other point down here for -2. And then I found my slope, plug it into point slope form, get it into slope intercept form. So my equation was -1.14x plus 2.57. The actual computer answer is -1.11x plus 2.27. So my line's pretty good. I would say an acceptable slope range would be -1.5 to -1, and an acceptable y-intercept range would be anywhere from like 2 to 3.